Good morning, class. We are looking at trigonometric functions, unit circle approach. Unit circle approach. So we looked at angles and their measurements. Now when we look at trigonometric functions, unit circle circle approach. And we want to find the objectives are to find the exact values of trig functions using a point on a unit circle, exact values of quadrantal angles, exact values of trig functions of pi over 4 45 degrees, pi over 6 30 degrees, pi over 3 60 degrees. Dylan, you have a question? Okay. And use a calculator to approximate the value of trig, and we are going to look at a circle with a radius r as well. So first, remember what we looked at. Various definitions. Vertex, line, ray. Here's the line. In essence, ray is a half line. Vertex. The initial side, the terminal side. Positive angle is counterclockwise, negative is clockwise. Standard position when the initial side is along the positive side of the x-axis. Quadrantal angles, right angle, straight angle. So initial side, terminal side, vertex, that's where the two angles come together. The two rays come together to create an angle. And as I mentioned, this is the initial side, is the terminal side. Negative side. Initial side, terminal side. Theta is in standard position. Theta is positive. Initial side, terminal side going clockwise. Theta is negative. Initial side, terminal side. This is 1/4 of a revolution or 90 degrees. This is half a revolution or straight angle or 180 degrees or pi radians. This is what we looked at. Also, we said 1 degree is 60 minutes. 1 minute is 60 seconds. So 1 degree becomes 3,600 seconds. And we use d over 180 is r over pi, omega. The angular velocity is theta over t, or 2 pi times rpm. V is s over t, or r omega, where s, the arc length is r theta, and the area of a sector is half of r squared theta. So this is the synopsis of everything we discussed. Now, I remind everybody that a circle centered at 0, 0 has an equation x squared plus y squared equals r squared. And if we set the radius equal to 1, becomes what we call a unit circle, because the radius is r. So look at those. So let t be a real number and let p with coordinates x comma y be the point on the unit circle that corresponds to t. So that's how we get things started. And of course, again, this is 1 0 0 1 minus 1 0 0 negative 1. All right, let's continue. X squared plus y squared equals 1. P has coordinates x comma y, and we define sine t to be y, cosine t to be x. That's how we define it. So sine t is y, cosine t is x. Let t be a real number and let p with coordinates x and y be the point on the unit circle that corresponds to t. The sine function associates with t the y coordinate of P and is denoted by sine t equals y. The cosine function associated with t, the x coordinate of P, and it's denoted by cosine is x. Now, the tangent function associated with t is the ratio of the y coordinate to the x coordinate. The tangent is defined as y over x. In essence, the ratio of sine to cosine. Then we have the reciprocals. Cotangent is the reciprocal of a tangent. Cosecant, the reciprocal of a sine. Secant, the reciprocal of a cosine. Therefore, when tangent is y over x, cotangent is x over y. Needless to say, the denominator can't be 0. When sine is y, cosecant must be 1 over y, the reciprocal of that. When cosine is x, secant must be 1 over x. All right, so this is the synopsis of what we've discussed so far. Now we want to find the exact values of all trig functions where p has coordinates -1/2 square root of 3 over 2. So it's a good practice to pinpoint that on the unit circle in a rectangular grid, if you will. And here's the coordinates. X is -1/2. Y is square root of 3 over 2. And we know that x represents cosine, y represents sine. Okay, so these two distances, this is the x coordinate, -1/2, this is the y coordinate, positive square root of 3 over 2. Therefore, sine is positive square root of 3 over 2 y, and cosine, which is x, is the x coordinate or -1/2. Now, as long as we have these two, we can find the rest of them. Remember, tangent is the ratio of y over x. So you divide this number by this number. And it's a complex fraction. The 2 drops. So you get minus square root of 3. The rest of them are the reciprocals. So right here, sine, we can find cosecant is the reciprocal of that, 2 over square root of 3. Cosine, the reciprocal. Secant is the reciprocal of that. That makes it -2. And tangent, cotangent is the reciprocal of that, 1 over minus square root of 3. So I hope you realize this is 2 over square root of 3. And if you multiply by square root of 3 over square root of 3, you get this. This one is very straightforward. And this one is 1 over minus square root of 3. Okay. And if I want to rationalize that, multiply it by square root of 3 over square root of 3, and it gives me this answer. That's just so you see how we arrive at it. Okay. Stop me if you have any questions, class. Now we want to find the exact value of the trig functions of quadrantal angles. Remember the quadrantal angles? There are angles that the terminal side is along the x or y axis. So look at this one. If we go with 0 degrees along the positive side of the x-axis, this point has coordinates 1, 0. And this angle is 0. So remember that x is cosine. Therefore, cosine of 0 is 1. And y is sine. And sine of 0 is 0. As long as we know those two, we can figure out the rest. So just look at these two, everybody. This comes from here. Look at this two. Okay, now I'll discuss the rest of them in a moment. But this comes from the coordinates 1, 0, right? And the fact that x is represented by cosine, y is represented by sine. What is tangent? Sine over cosine, 0 over 1. What is cotangent? What is the reciprocal of that? What is 1 over 0? We say undefined. UD, short for undefined. Cosecant. Cosecant is 1 over sine, so 1 over 0 is undefined. Secant is 1 over cosine, 1 over 1. The reciprocal of 1 is 1. Okay. 90-degree angle or pi over 2. Coordinates here are 0, 1. So that means cosine must be 0, sine must be 1. And again, I want you to concentrate on those two. Concentrate on those two. Sine is pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. Those are common arcs. We should know them. Now, what happens to the rest of it? Tangent. Sine over cosine. 1 over 0, undefined. Cotangent. Cosine over sine. 0 over 1, 0. Cosecant. Cosecant. 1 over sine. The reciprocal of sine. 1 over 1 is 1. Secant. 1 over cosine. 1 over 0. Undefined. So again, just to make sure everybody is comfortable with that, let me write this here. Cotangent, let's say t is 1 over tangent. Secant t is 1 over cosine. Cosecant t is 1 over sine. Those are the reciprocals. And as long as we have the first two, we can figure out the rest. And of course, tangent is sine over cosine. The next one is pi or 180 degrees. So look at this location having coordinates negative 1, 0. So cosine is negative 1, sine is 0. And again, let's concentrate on those two only. This is the result, right? Cosine, negative 1, sine 0. So cosine of a pi, negative 1, sine of pi, or 180 degrees is 0. Now, tangent is sine over cosine. 0 over negative 1 makes it 0. Cotangent is the reciprocal of tangent, 1 over 0, or you can say cosine over sine minus 1 over 0 makes it undefined. Cosecant, 1 over sine. So 1 over 0 is undefined. Secant, 1 over cosine. Here's cosine. 1 over negative 1. 1 over negative 1 is also negative 1. Reciprocals have the same sign. So we looked at 0 degrees, 90 degrees, or pi over 2, 180 degrees, or pi. Let's also look at 270 degrees, or 3 pi over 2. This time we have coordinates 0, negative 1. So cosine of 3 pi over 2 must be 0. Sine of 3 pi over 2 must be negative 1. Again, let me look at those two. Let me look at those two first. From right, the location 0, negative 1 here, right? What is tangent? Sine over cosine. Negative 1 over 0 is undefined. Cotangent, you can say cosine over sine. 0 over negative 1 is 0. Cosecant, 1 over sine. What is the reciprocal of this number? Is negative 1. And secant is the reciprocal of cosine. 1 over 0 is undefined. So as long as we know the first two, from the location of those points, we can figure out the rest. But ultimately, we need to memorize all of them. And those are common arcs, extremely important, everybody. Extremely important. All right. So now that we have shown those values, let's move on. And you have to remember first, if you look at this graph A, we have the terminal point here, P has coordinates X and Y. This is the theta. This is T, radians, S equals T units. And in this case, is T radians. Absolute value of T is less than 0 because we are going in a negative direction. If theta are T radians, the 6 trigonometric functions of angle theta are defined as sine theta equals sine T. So if we call that theta the angle, and remember that is the arc, this is the angle, okay? Sine theta equals sine T, cosine theta is cosine T, and so are the rest of them. So again, the arc versus the angle. Now, what you see here is what we discussed in the previous page, the exact values of the quadrantal angles. Quadrantal angles. That means theta equals 0, theta equals pi over 2 or 90 degrees, theta equals pi over 180 degrees, theta equals 3 pi over 2 or 270 degrees. We need to know all of them. And we come across them, and there will be quite a few more. Those are known as common arcs, common angles. And the quadrantal angles are very easy to memorize. Okay, so for example, pi over 2 or 90 degrees, the sine is 1. We have to be very comfortable with those. These are some of the common arcs. 0 pi over 2 pi, 3 pi over 2. And by the way, then we go back to 2 pi goes back to 0. So the same value. So if somebody says, okay, what about 2 pi? You get the same answers. Or 4 pi, or 6 pi, or 8 pi. When you go a complete revolution, it doesn't matter how many. So x and y are represented by cosine and sine. We want to find the exact values of the trig functions that are multiples of quadrantal angles. For example, 3 pi. Well, if you go a complete revolution becomes 2 pi and add another pi. So you end up here. And in this case, cosine is -1, sine is 0. We want sine, so the answer is 0. Now, another way of doing that, it's important to know a complete revolution is 2 pi. So if you said 3 pi minus 2 pi equals pi, and therefore is the same as sine pi, that works too, okay? Just for the sake of it. Now, this one, 270 degrees goes this way, minus 270 degrees goes that way. And what we do, we really end up negative 270 degrees, we end up at 90 degrees. Negative 270 is the same as 90 degrees. And over here, the coordinates are 0, 1. So cosine is 0, sine is 1. Because we want cosine, the answer is 0. Another thing I can show you here, if you happen to have a negative angle, and it may be difficult to figure out, and you want to make it positive as far as figuring out the functional value, add a complete revolution. If I add 360 degrees, I end up in the same location. And this is the same as cosine of 90 degrees or pi. Again, if you want to evaluate it, you can do that. A complete revolution brings you back to the same spot. So you add one complete revolution. If it's more negative, perhaps two, and so on and so forth. Find the exact values of the trigonometric function when pi over 4 is, when the function has the value of pi over 4 of 45 degrees. Well, let's see what we do. Because it's 45 degrees, it's on the line y equals x. The line y equals x is between the x and y axis, and it goes through the origin. So we have the formula for the unit circle x squared plus y squared equals 1. Because the point is on the line y equals x, we can replace the y with x and say x squared plus x squared. Because of this, we can replace this with x squared. Now 2x squared, so y equals x squared and x squared equals 1, and both of them are positive. So 2x squared equals 1, which means x squared is 1/2, and x is the square root of that, or 1 over square root of 2, or square root of 2 over 2. And therefore, this point P has coordinates. This point P has coordinates where x and y are both the same, square root of 2 over 2. And therefore, cosine of pi over 4 or 45 degrees is square root of 2. Sine of pi over 4 or 45 degrees is also square root of 2 over 2. So these are the coordinates. We proved the coordinates are square root of 2 over 2 and square root of 2 over 2. Therefore, sine and cosine are identical, square root of 2 over 2. What is tangent? Sine over cosine. The ratio of this number to this number is 1, and cotangent is the same, by the way, because cotangent is the reciprocal of tangent. If tangent is 1, so is cotangent. Now, what about cosecant? Cosecant is 1 over sine. So the reciprocal of this is 2 over square root of 2 or square root of 2. So let me, and the same thing goes for secant. Let me show you this one. Cosecant is 1 over sine. So here's sine. We want 1 over that. That means the reciprocal of that. 2 over square root of 2. You can multiply the top and the bottom by square root of 2, and you get square root of 2. I'm assuming you're okay with the algebra. So from here to here, I'm assuming you're okay with that, right? Again, I just can quickly show you. If you multiply this by square root of 2 over square root of 2, you get 2 square root of 2 over 2, which is square root of 2. So, in short, pi over 4 or 45 degrees. This is another common arc. Sine and cosine are both square root of 2 over 2. Tangent and cotangent are both 1. And you can figure out the rest. The reciprocal of those are square root of 2. We have those. I wrote them for you for now, but ultimately you must memorize those values because the pi over 4 is also considered a common arc, common angle. So what is sine of 45 times tangent of 45? You're supposed to know this is square root of 2 over 2 and this is 1. So the product is square root of 2 over 2. Again, I wrote this for now, but we must memorize. What about secant of pi over 4 times cotangent of pi over 4? We know secant is square root of 2. We know cotangent is 1. Their product is square root of 2. All right, sine 45 times cosine of 180. Okay, sine of 45 is square root of 2 over 2. Cosine of 180, negative 1. Their product is minus square root of 2 over 2. So we should know that. Tangent of pi over 4, 1. Minus sine of 3 pi over 2, negative 1. So 1 minus negative 1. That makes it plus 1. And it becomes 2. Secant of a pi over 4 is square root of 2 to the second power. Cosecant of a pi over 2 is 1 over sine of pi over 2. Remember, sine of pi over 2 was 1, so is cosecant because they're reciprocal. So this is square root of 2 to the second power, which makes it 2. This is 1. So this is square root of 2 to the second power. That means this is 2. By the way, you may not remember cosecant pi over 2. Just remember cosecant is 1 over sine, and you should know sine is 1. So the reciprocal of that is also 1. And they add up to 2 plus 1 equals 3. All right, let me remind you of a few things we have seen in the past. A triangle is a specific type of polygon having only 3 sides and 3 angles. The angle sum property of triangle, the sum of all interior angles of triangle, will always add up to 180 degrees. This is extremely important to remember, everybody. Again, it's very basic. We've seen it in algebra and you name it. Types of triangle with respect to the length of the sides. Scale triangle. All sides and angles have different measures. Isosceles triangle has 2 equal sides and 2 equal angles. Equilateral triangle. All sides and angles are the same. That means 180 divided by 3 makes it 60 degrees each. This is a general form. This is isosceles. 2 sides are equal, 2 angles are equal. This is equilateral, and all sides are identical, so are the angles. Just to refresh your memory. Types of triangles with respect to the angles. Right angle triangle, one of the 3 interior angles has a measure of 90 degrees. That means the other two must be less than 90 degrees because when they add up to 180. Acute angle triangle, all the three interior angles are acute less than 90 degrees. For example, this one, all of them are less than. Obtuse angle triangle. One of the three interior angles is an obtuse angle, which means has a measure greater than 90 degrees. Examples, this is a right triangle. This one is less than 90. We may not even know what it is, but this is clearly larger than 90 degrees. So just wanted to refresh your memory about various types of triangles and their names. We want to find the exact values of the trig functions for pi over 6 or 30 degrees, pi over 3 or 60 degrees. And here's how we start. We start with the right triangle of hypotenuse. We choose the hypotenuse, the largest side, the side across from the 90-degree angle is the largest side, is 1. Remember, the larger the angle, the larger the side opposite that, okay? So, and we choose this to be 30 degrees, we choose this to be 60 degrees, and we choose the side to be 1. One angle is 30 degrees or pi over 6, the other one is pi over 3 or 60 degrees. We make a second congruent triangle, something identical to that, and we put it on the right side of that. So what happens when we do that? Clearly, this was 1, this was 60 degrees, this was 30 degrees. So if this is 30, they add up to 60, and this is 60. Now you have 60, 60, 60. If all angles are identical, what do we have? The triangle is equilateral, so all sides must be 1. So if all sides are 1, and this is A, everybody, then 2A is 1, and A itself is 1/2. So if we choose this one to be 1, 30 degrees and 60 degrees, this proves this must be half of the whole is 1, and therefore it's 1/2. Now we use Pythagorean theorem on this side or that side, doesn't matter. A squared plus B squared, A squared plus B squared is C squared. Where we decided A is 1/2, B we don't have it. This side we don't have it. And C is 1. So obviously, I can subtract this from 1, and B squared becomes 3/4. And B becomes square root of that, or square root of 3/2. So what we did now, we have all those values. Okay, everybody? Meaning, if this side is 1, 30 degrees across from it is 1/2. 60 degrees across from it is the square root of 3/2. So we're going to put that on a unit circle. Remember, why did we choose this to be 1? So we can go with the unit circle. So we're going to put that in a unit circle and come up with trigonometric functions, the values of the trigonometric functions for those two important common arcs. So we're going to use this information to finish answering the question. Find the exact values of trigonometric function for 60 degrees. We proved this from the previous page. We put that into a unit circle. So this is 1. This is 60 degrees. Okay. Since this is 1, it's going to be on the circle. P has coordinates x, comma, y. And remember, This is b, this is a, this is square root of 3 over 2, this is 1/2. So x is 1/2 and y is the square root of 3 over 2, and x is what? Cosine. Y is what? Sine. Remember, x represents cosine, y represents sine. So practically we have everything we are looking for. So sine is y, cosine is x, tangent is the ratio of the two. Therefore, sine of pi over 3 or 60 degrees becomes square root of 3 over 2 according to this and this. Cosine of pi over 3 or 60 degrees become 1/2. As long as we have these two, we can find the rest of it. So tangent is the ratio of these two numbers, square root of 3 over 2 over 1/2. It simply becomes square root of 3. I hope you see that you can drop the 2 becomes square root of 3. So this 2 come from here or here, if you will. And the rest of them, we want to go with the relationship among those. Tangent is the ratio of sine to cosine. What about the rest of them? Very simple. What is the reciprocal of sine? Cosecant. So cosecant of pi over 3 or 60 degrees is 2 over square root of 3. If we multiply by square root of 3, if you multiply by square root of 3 over square root of 3, you get 2 square root of 3 over 3. Cosine, what is the reciprocal of that? Secant of pi over 3 or secant of 60 degrees is 2 over 1 or simply 2. Here's tangent. What is the reciprocal of tangent? Cotangent of pi over 3 or 60 degrees is 1 over square root of 3. And if I multiply it by square root of 3 over square root of 3 to rationalize, we get square root of 3 over 3. This is another common arc we should be very comfortable with. Sine of pi over 3, square root of 3 over 2. Cosine of pi over 3 is 1/2. From these two, we can create the rest of them. Tangent is the ratio of these two, which is square root of 3, and the rest of them are the reciprocals. Again, make sure you know these two, and everything else can be easily evaluated. As long as you know these two and tangent, then the rest of them are the reciprocals. You, in essence, you don't have to memorize them. Just make sure you know at least these two. I recommended 3, and the rest of them become the reciprocal. Now, we are going to use this concept that we learned, and in this example, we want to find the exact values of the trigonometric functions of pi over 6 or 30 degrees. And since this is 1, we can put that along the unit circle, and then we turn this around such that we are interested in 30 degrees. So we put it in this fashion. This is 1, but we put it such that 30 degrees. Opposite 30 degrees is 1/2. Adjacent to 30 degrees, square root of 3 over 2. And so therefore, your x coordinate or cosine is square root of 3 over 2. Your y coordinate or sine is 1/2. So from here, we put it in here. And then from here, we are going to write, again, sine is y, cosine is x, tangent is the ratio of those. So sine of pi over 6 or 30 degrees is the y, which is 1/2. The reason I write the sine first, because tangent is sine over cosine. I don't want to write cosine first. This is the cosine. So therefore, cosine of power 6 or 30 degrees is square root of 3 over 2. Again, as long as we have these two, we pretty much have the rest of them. Therefore, the ratio of these two is the tangent. So 1/2 over square root of 2 over 2, the 2's cancel out. It's 1 over square root of 3. This is 1 over square root of 3. And if you multiply by square root of 3 over square root of 3, you rationalize. Now, the rest of them, just write the reciprocals. And we did the reciprocals before, so I'm not going to go over the rationalization. Reciprocal of this is 2. Therefore, cosecant of pi over 6 over 30 degrees is 2. Reciprocal of this is 2 over square root of 3. Therefore, secant of pi over 6 over 30 degrees is 2 over square root of 3. Remember, I showed you times square root of 3 over 3. We get 2 square root of 3 over 3. And in this case, cotangent is 3 over square root of 3, cotangent of 30 degrees. And I hope you know that this is square root of 3 because you can divide 3 by square root of 3 in that fashion. So again, if you don't know all of it, as long as you know the first two, sine and cosine. Okay, so this is cosine, this is sine. You are in good shape, okay? And that is extremely important to pay attention to. This is an interesting question. A rain gutter is to be constructed from a metal sheet of width 12 inches. By bending up 1/3 of the sheet, so 4, 4, 4, 1/3 of it, each side, through an angle of theta. So when you bend it, it looks like that. Prove that the area of this opening, this area, A of theta is 16 sine theta times cosine theta plus 1, and find the area when theta is 30, 45, 60. Those are not a big deal. As long as we have that, you just replace the sine with 30, 45, 60. Those are our common arcs you come up with the S. The main thing is to prove that. And to prove that, you need to recognize this shape and know that, and by the way, this is 4, and this becomes 4 cosine theta. This angle theta, let me have something here. This angle theta is the same as this one, it's the same as this one. And therefore, this distance from here to here, this distance is 4 times cosine theta, because cosine theta is the adjacent over the hypotenuse. So since we want the adjacent is the product of these two, hypotenuse times cosine theta. And hypotenuse is 4. Hypotenuse is 4. So I hope everybody can see that how we get to 4 cosine theta. All right, so the area is half of the height times B1 smaller base plus B2 larger base, and this is the height. Let me clean this up. Actually, let me clean everything up so we can plug it. 1/2 the height times b1 plus b2. Now, this was 4 cosine theta. What is this one? The height is 4 sine theta. The height is 4 sine theta. So again, look at if I want to show this one here. This is 4. This is theta. And if you work it out, this becomes 4 cosine theta. This becomes 4 sine theta. And again, because sine theta is the opposite over the hypotenuse. And cosine is the adjacent, the one next to it, over the hypotenuse. These are some basic from a right triangle everybody remembers. And for that, this is the height for sine theta, the height for this triangle. Okay, and this is for cosine theta. Therefore, when we look at this side, the smaller base is 4. This is the larger base, which is this one plus this one plus this one. This one is 4, and this one is 4 cosine theta. This is also 4 cosine theta. That's why b sub 2 is 4, the one in the middle, and on each side we have 4 cosine theta, which makes it 4 plus 8 cosine theta. Again, I need to clean up the mess. Okay. All right, what happens next? According to this formula, area is 1/2 the height for sine theta, and then b1, which is 4, plus b2, which is all of those. We are going to simplify. We are going to simplify. How do we do that? Just do this. This 2, this 2, this 2. This is what we get. So we have 2 sine theta times 8 cos theta, and you can take the 8 out here. And 8 times 2 gives you this 16 times 1 plus, which is, so it's very straightforward. So going back, just to make sure we understood that, area is 1/2 h times b1 plus b2, the area of a trapezoid. Trapezoid. So let me, maybe I write that. Trapezoid. That's why. And we are done. We just plug in now. When theta is 30 degrees, we want a of 30, 16 times sine 30 degrees, cosine 30 degrees plus 1, or 1 plus cosine 30. I wanted to follow that, and that's why I wrote that. And sine of 30 is 1/2. Cosine of 30 is square root of 3/2. This is 8. When you distribute, you get 4 square root of 3 plus 8. This is an exact answer, everybody. Exact answer. And you can do the approximation. Okay. Now, what about 45 degrees? Well, the same thing. Just plug in and observe, and sine of 45 degrees square root of 2, cosine of 5 degrees is also square root of 2/2. And so you notice if you multiply, and by the way, this one and this one, they cancel each other, they give us 8. Square root of 2 and then 8 square root of 2. This is again exact. And approximation gives us 19.31. As always, you write the units, in this case, inch squared. If you go with 60, 16 sine of 60, cosine of 60 plus 1. Sine of 60 is square root of 3/2, and cosine is 1. Again, we can cancel the 2 with 6, and all time we get the exact answer, 12. Approximation of 20.78 inch squared. All right, let's move on. These are common arcs. I'm assuming we are comfortable with those. X squared plus y squared equals 1 and so forth. So exact values of the trigonometric functions for integer multiples of pi equals 45 degrees, the power 4 or 45 degrees, power 6 or 30 degrees, power 3 or 60 degrees. How does that work? Basically, what you need to know is this. If you go with power 4 here, it's square root of 2 over square root of 2. If you go through the origin, you end up here with 5 pi over 4, and you have the same values but negative, because in the third quadrant, both of them are negative. Remember, cosine is the x value and sine is the y value. In the third quadrant, both are negative. If you go to the second quadrant, okay, in the second quadrant, x is negative, so cosine becomes negative, and y is positive. In the fourth quadrant, x is positive, that means cosine is positive, and y is negative, that means sine is negative. So that's something you want to remember. So the first quadrant, class, x and y are both positive. The second quadrant, x is negative. The third quadrant, both of them are negative. And the fourth quadrant, y is negative. And remember, x means cosine, y means sine. If you remember that, you can remember all of this. So for example, if you look at this one, this is 3 pi over 4, right? So the same values that we have here, but we have to account for negative or positive. In the second quadrant, x is negative, so cosine of 3 pi over 4 is minus square root of 2 over 2, but sine is still positive. And 5 pi over 4, 7 pi over. If you go with this angle, pi over 6, and you know that x or cosine is square root of 3/2, y or sine is 1/2. When you go to the third quadrant, both of them become negative. But in the second quadrant, x becomes negative. That means cosine is negative. And in the fourth quadrant, y is negative. That means sine is negative. If you look at pi over 3, works out in the same manner. So please make sure you follow and understand those common arcs. Then pay attention to where x or y is positive or negative. First quadrant, we don't have to worry about it. Again, Second quadrant, x is negative. Third quadrant, both of them are negative. Fourth quadrant, only y is negative. Y means sine, x means cosine. If you remember that, you can easily come up with the answer. All right. Cosine of 150 degrees or 5 pi over 6. And that's minus square root of 3 over 2. Because cosine is represented by x. Okay, so you remember this one. Cosine is represented by x. Sine of negative 30 degrees or negative pi over 6, either way. And remember, this was pi over 6, and sine is 1/2. This is negative in the negative side or clockwise, and that's negative 1/2. Tan of 4 pi over 3, you can just look at sine and cosine and the ratio. Or better yet, I'm going to add something to that. In the third quadrant, class, because it's larger than pi and less than 3 pi over 2 is in the third quadrant. In the third quadrant, tangent and cotangent are positive because in the third quadrant, sine and cosine are both negative. The ratio is positive. So in the third quadrant, tangent and cotangent are both positive. Sine of 7 pi over 6. That puts us in the third quadrant. And in the third quadrant, both sine and cosine are positive. So think about this pi over 6 as the reference arc. The sine of pi over 6 is 1/2. This is negative because it's in the third quadrant and therefore becomes negative 1/2. So pay attention to the quadrant of interest. Use a calculator to approximate the value of a trig function. So let's see how we do that and we remember all of this. For example, we are interested in calculating cosine of 48 degrees. When you get to common arcs, you should remember, and when it's not common arcs, we can use a calculator. So I want to quickly show you what happens. So you use a calculator, cosine of 48 degrees, and it gives you the answer. You want cosecant of 21 degrees. You know, cosecant is the reciprocal of sine, so you put 1 over sine of 21, and you come up with the answer. Now, tan of pi over 12, what I want to make a point of, you put tan of pi over 12, you come up with the answer. It's important to change the mode to radian. If you're dealing with calculators, they may be in radian mode, they may be in degree mode. Let's say I'm not too sure in what mode they are. And one way to check it, use one of those common arcs. For example, if you put sine of 30, it should give you 1/2. If it does, it means it's in degrees mode. If it's not, it's in radian. Okay. Otherwise, you can choose the mode. For example, we change this to radian mode for tangent, and tan of pi over 2 is that. That's where we have it. I hope everybody's clear. You want to pay attention to this. Is it in radian? Is it in degrees? And if it's not right, it will not give you the correct answer. Use a circle of radius r to evaluate the trig functions. Remember, we used the unit circle of x squared plus y squared equals 1 squared root of 1. But what if it's r? Now, this one, x squared plus y squared equals 1, versus something that the radius is something other than 1. So we call it r in general. So what happens to the formulas? We write x squared plus y squared is r squared. any point has coordinates x, comma, y, let's call it A and B. Then the sine theta, and remember they are larger than 1. Remember, sine and cosine are within -1 and 1. So sine would be y over r or b over r. Cosine will be x over r or a over r. And again, I want you to pay attention to those two, because if we know those two, okay, the rest of them are very simple. Sine was y, now it's y over r. Cosine was x, now it's x over r. Now what is tangent? Sine over cosine. If you divide this one by this one, r drops, becomes y over x. The rest of them are the reciprocals. Therefore, cotangent becomes x over y. Cosecant is 1 over sine, r over y, and secant is r over x. Okay. Let's find the exact values of the 6 trigonometric functions of a positive angle theta if this pair 4, -3 is a point on its terminal side. So we have the point. So let's come up with the point. Let's show where the point is. That means on a circle. So this has coordinates 4, -3 is a point on the terminal side. Okay. We have to evaluate the r. So let's go through the process. P has coordinates x, comma, y, or a and b, 4, -3. And r is square root of a squared plus b squared. R is the square root of a squared plus b squared, Pythagorean theorem. So 4 squared and -3 squared is 16, and +9, they add up to 25, and the square root of that is 5. I'm assuming no one has any problem calculating this. Okay. So now we follow. What is sine theta? Y over r, -3 over 5. What is cosine theta? X over r, 4 over 5. What is tan theta? The ratio of those two, -3 over 4. So sine theta is b over r or y over r. Cosine theta is a over r or x over r. And tan theta is b over a. So those are the values. The rest of them are the reciprocals. So cosecant is 1 over sine or -5/3. Secant of theta is 1 over cosine or 5 over 4. Cotangent is 1 over tangent or -4/3. So the rest of them are the reciprocals. So find, in fact, not even the third one. As long as you find these two, the rest of them become nice and easy. Very straightforward, everybody. All right, let's continue with the thoughts. Find the exact values of each expression, where we are reminding everybody of a pi over 4. Cosine and sine are identical, square root of 2 over 2. If you continue to go to the third quadrant, this is 5 pi over 4. If you go to the second quadrant, is 3 pi over 4. If you go to the fourth quadrant, is 7 pi over 4. All of them have pi over 4 as what we call as a reference arc. So let me just write that actually. So in this example, this is considered the reference arc or angle. Okay. So which means all of them, they go with those values. You have to figure out the negative or positive. So 135 degrees, okay, has coordinates and negative square root of 2 and square root of 2. You want cosine, which is the x coordinates. In the second quadrant, x is negative, so it becomes minus square root of 2 over 2. For 3 pi over 4, 3 pi over 4 class is the same as 135 degrees. This is in degrees, this is in radians. We have the same situation. We want the tangent is the ratio of these two. And ratio of these two is 1. Negative makes it negative 1. Negative 1. 225 degrees. 225 degrees is the same as 5 pi over 4 in the third quadrant. And in the third quadrant, sine and cosine are both negative. We are interested in sine of 225 degrees, so it's minus square root of 2 over 2, the y coordinate. Minus 5 pi over 4. We start from here. This is pi, and this is minus 5 pi over 4. So 3 pi over 4 and negative 5 pi over 4, they have the same terminal side. This one, the same terminal side as 3 pi over 4. Cosine is the x coordinate minus square root of 2 over 2. 9 pi over 4. Remember, 8 pi over 4 is 2 pi. So 9 pi over 4, that means go a complete revolution and come back to pi over 4. So this is the same as pi over 4 for the terminal side. This one, the same as pi over 4. So this location, and with this location, we are interested in sine. Sine is the y coordinate, is the square root of 2 over 2. What I want to add is what I mentioned in the beginning, the concept of a reference arc. Use reference angle or arc, theta hat. Sometimes they call it theta prime, okay? Theta hat or theta. And look at the quadrant. In the first quadrant, the reference arc is identical to theta. So in the first quadrant, this is not only your theta, it's also theta hat. In the second quadrant, the reference arc is pi minus theta. It's the smaller, the closest angle to theta. So for this one, for example, 3 pi over 4, you would put pi minus 3 pi over 4, which still makes it pi. All of these angles, pi over 4 is the reference arc. If we go to the third quadrant, now the theta is 5 pi over 4 minus pi and makes it again pi over 4. If you go to the fourth quadrant, 2 pi minus 7 pi over 4, all of these have the reference arc of pi over 4. Now, what does that mean? You just concentrate on these two pairs and then figure out the sign based on the quadrant. So for example, if you're dealing with 3 pi over 4, it's in the second quadrant, you know x is positive, y is negative. That makes it that cosine becomes negative and sine becomes positive. And that's all there is to it. So you, okay.